Lesson 3-7, solving inequalities by multiplying or dividing. And in this lesson, you learn to solve inequalities by using the multiplication and division properties of equality. Let's take a look at this example in recycling. Environmental protection is an ever-growing concern for the world, even when we pollute our environment. So when we pollute our environment, we are polluting our living space. Recycling materials is a good way to keep our habitat cleaner. By weight, the reuse of steel paper lead the way. The recycling of steel by weight is greater than that of paper. So on our horizontal bar graph, we can see that steel is way greater than paper recycling. Okay, so how does this? What does it have to do with what we need to learn? We can use those comparisons by what we call inequalities. The comparison of paper to steel recycling provides a way to look at inequalities. Rounding the weights, 35 million tons of paper being recycled is less than 64 million tons of steel being recycled. So in symbols, it is 35 less than 64. Okay, and it is estimated that people use 4 times as much paper and steel as they recycle. Does the inequality between paper and steel keep its order for the amount used? That's a good question. Now, if they say that people use 4 times as much paper as steel, then we can create an inequality such as 35 times 4. Okay, is it less than 64 times 4? And if you notice, okay, the inequality will remain. 140 is less than 256. The inequality is still true. Another way people can help the environment is to use as little of these products as possible. What if people cut the amount of paper and steel that they use in half? Will this affect the inequality? Let's find out. So let's say you have 140 is less than 256, and that is the original amount of tons of paper and steel used. Okay, and let's say we divide both of them by 2. So will the inequality still be unchanged? Okay, and if you notice, it will still be unchanged. The inequality is still true. Okay, these examples suggest the properties, okay, that we are going to talk about, and these are the multiplication and division properties of inequalities, which simply states in words: when you multiply or divide each side of a true inequality by a positive integer, the result remains true. Take note, positive integer, because we're going to talk about negatives later on. Okay, so this is a good uh, uh, one thing to think about, because later on when we deal with a negative integer, okay, it'll be quite different. So the result remains true for all integers a, b, and c, where a is greater than 0. If a is greater than b, then a times c is greater than b times c, and a over c is greater than b over c. Okay, so basically we're saying is that if we multiply both sides of the inequality with the same number, or divide both sides of the inequality with the same number, okay, uh, uh, for as long as it's a positive integer, then you will have the inequality will not change. Okay, and the rule is similar for a less than b, a greater than or equal to b, and a less than or equal to b. So if it follows for all 3 inequalities as well. Okay, next we need to consider if an inequality remains true even if we multiply or divide each side by a negative number. Remember, the rule talks about a positive number. Okay, let's consider the inequality 6 less than 10. Okay, and if we multiply each side by negative 1. Okay, so you have 6 less than 10. Okay, and we want to multiply each side by negative 1. Now, if you notice 6 times negative 1, is it less than 10 times negative 1? This becomes negative 6 is less than negative 10. The result will be false. Okay. Now let's try negative 2 and see if it's still false. So you have 6 less than 10, divide both sides by -2, we end up with -3 less than -5. So if we multiply or divide each side by a negative number, the result would be a false inequality if we keep the inequality symbol. So the inequality is -6 less than -10 and 3 less than -5 obviously are both false. Notice that both inequalities would be true if you reverse the order symbol. Okay, so if we reverse the order symbol from less than to greater than, okay, and from less than to greater than, then the inequality would be true. So in this case, if I reverse the order symbol, -6 greater than -10, and in this case -3 greater than -5, okay, both inequalities remain true. Okay, now these examples follow our next rule, okay, next property, and the next property is this. In words, when you multiply or divide each side of an inequality by a negative number, now we're going to talk about a negative number, you must reverse the order symbol. Okay, so for all integers a, b, and c, where a is less than 0, if a is greater than b, then a times c is less than b, okay, and b times c, and a times c is less than b times c, and a over c is less than b times c, provided that c is a negative number. Okay, again, when you multiply or divide each side of an inequality by a negative integer, you must reverse the order symbol of the inequality. And this rule is similar to if a is less than b, a is greater than or equal to b, and a is less than or equal to b. So these rules apply to these three inequalities as well. Those three situations right here. Okay, let's take a look at how this works in example number 1. Solve each inequality and check the solution, then graph the solution on a number line. You have 4x less than -28. Okay, like what I've been telling you all along, you need to copy the problem, and 4x less than 28. After copying the problem, we want to solve for x. And in order to solve for x, we need to divide both sides by 4. To divide both sides by 4, we end up with x is less than -7. Okay? And then we check our answer. We try -10. Why -10? Because -10 is a value that is less than -7. You can try -9, you can try -11, any value less than -10. Okay? So we use -10, easier to substitute. So you have 4 times -10, is it less than -28? The answer is true. Now, if you notice, we did not reverse the order symbol. Why? Because we divided both sides by a positive number. Okay? And then it says there, graph the solution set on the number line. So the solution is all numbers less than 7. Okay, and therefore, since it's a less than sign, you'll have an open dot on -7 going to the left. So an open dot on -7 going to the left. Let's try example 1b. You have m less than -3 is less than or equal to 4. We want to solve for m. That means we need to undo -3, and the fraction bar indicates division. So first and foremost, we copy the problem again. M less than -3 is less than or equal to 4. Okay, and then we multiply both sides by -3. But remember, because of the multiplication division properties of inequality, where you are dividing each side by a negative number, you reverse the order symbol. So from less than or equal to, it becomes greater than or equal to. Okay, that is because we are now dividing both sides by multiplying both sides by a negative integer. So when we multiply both sides by a negative integer, we immediately reverse the order symbol, in this case from less than or equal to greater than or equal to. Okay, the negative 3 goes away because that's equal to 1. So you now have m is greater than or equal to negative 12, because 4 times negative 3 is negative 12. So we check our answer. We want to find a value of m that is greater than negative 12. Okay, and 0 is a good number. That 0 is a number greater than negative 12. We substitute the value of 0 to the inequality. Okay, m less than negative 3 less than or equal to 4 is our inequality. Substitute 0. Is it less than or equal to 4? Is 0 is less than or equal to 4. Therefore, our answer checks out. Okay, so the solution is all numbers greater than 0, greater than or equal to negative 12. The graph is shown below. Okay, and this is our graph. Remember, it's a less than or it's a greater than or equal to sign, meaning you have a close dot, and since the inequality is pointing away from the variable, okay, the arrow points to the right. So it's a close dot on negative 12 and the arrow going to the right, exactly as you have there. Okay, last example. Let's take a look at Carissa's example. Nope, not that one. It's Carissa's example right here. Right there. There you go. Okay. Example number 2. Inequalities are often used to solve problems involving money. Carlissa earns $5 per hour bussing tables at the Italian eatery restaurant. How many hours must she work to earn at least $110 each week? Okay, again, a word problem. And in any word problem, we need to define our variable. And in defining our variable, we get in this problem, our variable will be coming from the question of the problem, which is how many hours must she work to earn at least $110 each week. So in defining a variable, what do? We always start with a let statement. Let x represent the hours required to earn at least $110. Now we define our variable, we create our inequality, we make our inequality to be 5x is greater than or equal to 10. Why 5x? Because 5 represents $5 per hour that she works bussing tables. Okay? And x represents the number of hours. And then we solve for x. We divide both sides by 5. Since we are dividing by a positive integer, okay, we do not reverse the order symbol. So you end up with x greater than or equal to 22. Okay? In words, Carlissa must work at least 22 hours to earn at least $110 a week. Okay? And that's how you use inequalities to solve that word problem. Okay? And that's the end of our lesson. So, on Google Forms or My Big Campus, okay, type a summary of what you've learned by responding to the objective of the lesson, and type a question you may want to ask in class about this lesson. Thank you.